Welcome back to God Maths. This is where mathematical literacy begins. Today we'll continue with our lesson on indices and also discuss exponential equations. Before we get started, do not forget to subscribe to this channel for more video lessons. Let's check the solutions to our previous assignments on indices. Those were the solutions to the previous assignments. Now let's take further examples on indices. Let's go through the following questions. First one is and that is equal to, we have learned from the basic principle that square root is the same as raised to the power half. And then when two multiplying numbers have a common exponent, then they both take the exponent. So we will have, then b power 24 will also take that exponent. 2 cancels 8 to give us 4. Then 2 cancels 24 to give us 12. Let's take our second question. We have 100 over 9. All taking the power 3 over 2. And that should be equal to, we know 100 can be written in the index form as 10 times 10, which will give us 10 squared. 9 can also be 3 times 3, which will give us 3 squared. So we will have 10 squared over 3 squared, all raised to the power 3 over 2. This will give us 10 raised to the power 10 squared, all raised to the power 3 over 2, divided by 3 squared, all raised to the power 3 over 2. And that will give us 2 cancels 2, 2 cancels 2. So we have 10 to the power 3, 3 to the power 3. And then that gives us 10 over 3, all to the power 3, since they have a common power. Then our third question, we have 6x y cubed 3x negative 1y, all raised to the power 3. And that gives us, first you should know 3 can cancel 6 to give us 2. And that will give us 2x y cubed all to the power 3 over x minus 1y all to the power 3. The numerator takes the power, the denominator takes the same power. And that will give us, all the elements here will take this power. So we have 2 to the power 3, x to the power 3, y to the power 9, which is this 3 times the next exponent. Here we will have x to the power negative 3, 3 times negative 1, and then y to the power 3. That is going to give us 2 raised to the power 3 will give us 8. Then we have x to the power 3, y to the power 9, times x to the power 3, y to the power negative 3. We have said that when a denominator is written as a numerator, then the exponent will change to the opposite. So next we will have x and x are common, and so since they have the same base and they are multiplying, we will have x to the power 3 plus 3, that will give us 6. Then y and y are also common. They have the same base, so the powers will add, and that will give us 6. 9 plus negative 3 will also give us 6. Then our last question, we have 3 minus 5n times 9n minus 1 times 27n plus 1. And that will give us, if you want the bases to be the same, we know 9 can be written as 3 times 3, which will give us 3 squared. 27 will be 3 times 3 times 3, which will give us 3 to the power 3. And so we will have 3 negative 5n times This 9 will be written as 3 squared, and it is raised to the power n minus 1. This 9 raised to the power n minus 1. And 27 will be 3 to the power 3. It's also raised to the power n plus 1. So 3 negative 5 times, the property says the powers will multiply. So since it's n minus 1, we will have 3 to the power 2 multiplying n minus 1 will give us 2n minus 2. 2 times n, 2 times 1 times, here 3 will multiply this power, and that will give us 3n plus 3. So since the bases are now the same, we can maintain the base and add the exponents. This is one exponent and another exponent. So we will finally have, this is minus 5n. We will finally have negative 5n plus 2n will give us negative 3n plus another 3n. Let's put them together. So we have negative 5n plus 2n plus 3n. Then for the numbers, we have negative 2 plus 3. This will give us 3 raised to the power, all this will give us 0 plus 1, negative 2 plus 3. So we have 3 raised to the power 1, which is equal to 3. Next, we will look at exponential equations. Some equations have their unknown variables as exponents, and these are the equations which are termed exponential. And so exponential equations are those equations whose unknown variables are exponents or indices. Let's look at this example. This is an equation since there is an equal sign, but the unknown variable is an exponent. How do we find this? First, we must make sure that the bases are the same. Then we can equate the exponents. And 8 can be written in base 2 as 2 raised to the power 3. 8 is 2 times 2 times 2. And that gives us 2 raised to the power 3. Since the bases are the same, we can equate the exponents. Let's take another example as 3 raised to the power x minus 1 is equal to 27. 27 can also be written in base 3. And so we will have 3 raised to the power x minus 1 is equal to 27 is 3 times 3 times 3, which will give us 3 raised to the power 3. And now since the bases are the same, we will have the exponents to be equal. So x is equal to 3 plus 1, which will give us 4. Note that in solving exponential equations, the idea is to make sure that we have the same base and then we can equate the exponents to find the unknown variable. Let's take more complex questions under this. Let's go through these examples. X plus 3. In solving equations that involve fractions, we multiply through by the LCM of the fractions. Here we have only one fraction with this LCM. So we will multiply through by the LCM. And this will cancel that. We will now be left with 9. 2x minus 3 is equal to 3x plus 3. In solving exponential equations, we must get the numbers in the same base. And 9 can be written as 3 raised to the power 2. And that is all raised to the power 2x minus 3, which gives us 3x plus 3. Here, the powers will multiply. And that will give us 3 raised to the power 2 times 2x will give us 4x. 2 times negative 3 will give us negative 6. Since the bases are the same, we can now equate the exponents. And this can be solved by grouping of like terms. Let's go to our second example. We have 1 over 81 to the power x minus 2, that is 27, 1 minus x. Now, in solving equations, the same way we multiply through by the LCM, and that will give us 1 is equal to 27, 1 minus x, all multiplied by 81 x minus 2. Then we have to get the numbers in the same base. How do we get these numbers in the same base? 1 is any number raised to the power 0. How do we get the bases here? 27 can be written as a number in base 3 as 3 raised to the power 3. And that is all raised to the power 1 minus x times 81 can also be written as a number in base 3 as 3 raised to the power 4. And that is all raised to the power x minus 2. 1 will also be written as 3 raised to the power 0 because we want to get the same base. Then that will give us 3 raised to the power 0 is equal to, here we will have 3 raised to the power 3 minus 3x times 3 raised to the power, this will give us 4x minus 2. Then we know that if the bases are the same and they are multiplying, we add the exponents, and that will give us 3 raised to the power 0 is equal to, we have 3 raised to the power, we maintain the base, 3 minus 3x plus 4x minus 2. So we will have 0 is equal to 3 minus 3x plus 4x minus 2. The bases are the same and we are equating the exponents. Let's add the numbers to get 7. 3 minus 2 will give us 1. Then negative 3x plus 4x will give us x. Now we want to group like terms. So x will move to this side to become negative x equal to 1. We divide both sides by negative 1. Imply that x is equal to negative 1. Let's take our third question. How do we write these numbers in the same base? 128 can be written as 2 raised to the power 7. And so we will have 3x minus 1 is equal to 2 raised to the power 7 times 2 raised to the power, square root of 2 is 2 raised to the power half. We can put times here. We have done this one. And we will have 2 raised to the power 3x minus 1 is equal to 2 raised to the power 7 plus half. The bases are the same and they are multiplying. Now, since we have the same base, we can equate the exponents as 3x minus 1 equal to 7 plus half. This is an equation involving fraction, and we multiply through by the LCM of the fractions, which in this case is 2. So we will have 2 times 3x minus 2 times 1 plus, that is equal to 2 times 7 plus 2 times half. And so we will have 6x minus 2 is equal to 14 plus 2 cancels 2, and we have 1. So 6x is equal to 14 plus 1 plus 2. 6x will give us 17. And then we divide through by 6 to have x is equal to 17 over 6. Now we will take our assignment for today's lesson. Try as much as possible to solve these questions on your own. If you have any difficulty, you are always free to contact us via our WhatsApp numbers given in the video description. In our next lesson, we will look at logarithms. But before you sign out, remember to subscribe to this channel and share this video. See you in our next lesson.